Okay, good morning, everybody. Today we'll take up the second lesson in surveying as a part of basics of civil engineering. That is, topic is horizontal or linear measurements. This is by G. Nagesh Kumar, Senior Assistant Professor, Civil Engineering Department, G. Pullardi Engineering College. Our first topic is what is meant by linear measurement. The determination of the distance between 2 points on the surface of the earth is one of the basic operation of surveying. So measurement of the horizontal distances or measuring the linear measurement is required in chain surveying, traverse surveying and other types of surveying. Next we'll study about what are the methods of making linear measurements or horizontal measurements. The first one is approximate methods and later one is direct methods. Generally we'll follow in surveying direct methods, and next is optical methods, and last one is that is advanced method, that is called EDM methods. Now we'll discuss each one about a little bit, each one method. The first one method is approximate methods. The method given below may be used in reconnaissance survey or for detecting the major mistakes in linear measurements obtained with a chain or tape. The first method is approximate method is pacing. A distance between 2 points can be approximately be determined by counting the number of paces and multiplying it with average length of the pace. See, that is counting 1, 2, 3 like that one, 58, 59 shown in the pace length is shown at here. The pace length is 1 foot to, okay, back. The phase length is 1 point, okay, whatever that. This one is one phase length. So by simply counting, you can get the number of paces. Step counter can also be used as a passometer, another instrument called passometer, to count the number of steps. Another instrument is called pedometer. Pedometer counts the paces and multiplied with the distance of each pace will give the distance also directly in this. And next type of instrument is odometer. Pedometer. This instrument directly gives the distance by multiplying the number of paces with the average pace length of the person carrying the instrument. That is a paceometer. Pedometer. Pedometer is another instrument which can be fixed to the body, so which counts the distance also directly, which gives the distance. Next is a odometer. An odometer is a simple device which can be attached to the wheel or of a bicycle or any such vehicle. The odometer registers the number of revolutions made by the wheel. The distance covered is equal to the product of the number of revolutions and the perimeter of the wheel. So this is an example for odometer. Last one is a speedometer. This is generally used in automobiles for measuring the distances. Also, the velocity of vehicle can also be measured at here. Next type of approximate measuring instrument is measuring wheel. Generally in the construction purpose for the laying pipelines, canals, etc., the measuring wheel is used. So it is a wheel fitted with a fork and handle. The wheel is graduated and shows a distance per revolution. There is a dial which records the number of revolutions. Thus, the distance can be easily computed. Most probably, the perimeter of the wheel may be kept as 1 meter or a 1 yard. So that by counting, the counting machine counts the number of revolutions and multiplied with the 1 meter will give the total distance. So this is another example. So at here you can see that recording will be done at here, number of rotations. When coming to the second method, that is a direct method. In the direct method, the distance is actually measured during field work using a chain or tape. This is the most commonly used method for linear measurement. And coming to the third method, in that we will discuss the direct method in detail in the coming slides. In the third method, that is the optical method, principles of optics are used. The distance is not actually measured in the field, but it is computed indirectly. The instrument used for making observations is called tachometer. Most probably a theodolite may be used as a tachometer. In this one, see, this is an optical instrument. So at here, the distance between the 2 points, the distance between the S value is computed. The staff is kept over the station B from the optical instrument A from station. So multiplying this S value with the some constant given with the instrument, we will find out the distance, horizontal distance. If the line of sight is inclined, then we have to use the trigonometrical functions along with the S value so that you can easily compute the distance. Next type of instrument is distance measurement is called electronic distance measuring instrument, have been developed quite recently. These are practically replacing the measurement of distances using chains or tape. There is a large variety of such instruments, and depending upon the precision required, the instrument should be used. In this one, in the case of a EDM, we will use the electromagnetism. So electromagnetism waves are generated from the EDM, and these waves will be reflected back through a prism kept at the point whose distance has to be known. This reflected wave will again reach to the EDM. EDM consists of a microprocessor which processes this wave propagation and calculates the distance between the EDM and the prism, which is an object. So directly the distance is displayed on the screen. This is an advanced instrument which can be used for more accurate measurements. Next, coming in detail about the direct method, that is chain surveying. The chain surveying is the type of surveying in which only linear measurements are taken in the field. This type of surveying is done for surveying of a small extent to describe the boundaries of plots of land and to locate the existing feature on them. In this, it is the method of surveying in which the area is divided into network of triangles and the sides of the various triangles are measured directly in the field with a chain or a tape, and no angular measurements are taken. So the next is the principle of chain surveying. The principle of chain surveying is to divide the area into number of triangles of suitable sides, as a triangle is the only simple plane geometrical figure which can be plotted from the length of the three sides, even if the angles are not known. A network of triangles is preferred in chain surveying. Triangulation is the principle of chain surveying. If the area to be surveyed is a triangle in shape, and the length and sequence of its three sides are not recorded, the plane of the area can be easily drawn. So like this one, the principle can be applied. So by knowing the three sides of the triangle ABD, you can able to calculate the area also. Similarly, BDC. Also, you can find out the area. By knowing the three sides, you can easily plot them also on the drawing sheet or on the computer screen. These are the general terms used in chain surveying. That is, the triangle is marked with a station. This is a station, survey station. So entire area is subdivided into number of triangles. This is one triangle. This is a one triangle. This is another triangle. Like that one. The line connecting the main survey stations A and B is called main survey line. Similarly, B and C will also be called main survey line. And the longest line in the main survey lines will be called as a baseline. So along the baseline, all the measurements are taken with reference to the baseline. And for checking the accuracy of the work, a check line may be marked from the station to the baseline. Similarly, from C station to S2 is a back line. And to know the, because we are not taking the angular measurements, so by taking a tie line, we can check the angularity between these two lines, can be easily measured. Now we'll see what are the instruments used in chain surveying. The following instruments are used while chaining: chains, tapes, arrows, ranging rods and offset rods, pegs, plumb bob, line ranger. We'll discuss briefly about those instruments. First, coming to the chains, various types of chains used in surveying are metric chain, gunter's chain, surveyor's chain, engineer's chain, revenue chain, and steel band or band chain. I will discuss in detail about the metric chain. Metric chain is generally used. Normally, this chain consists of a galvanized mild steel wire of 4 mm diameter known as link. The ends of the links are bent into loop and connected together by means of 3 oval rings, which provide the flexibility to the chain and make it less liable to nicking. Both ends of the chain have brass handle with a swivel joint so that the chain can be turned round without twisting. In a metric chain, at every 1 meter interval of chain, a small brass ring is provided. The brass tallies are also provided at every 5 meters length of chain. Each tally has different shape which indicates 5 meters, 10 meters, 15 meters from any one side of the chain. Metric chains are available in 20 meters and 30 meters in length. A 20-meter chain has 100 links, each of 20 centimeters, and a 30-meter chain has 150 links. Length of chain is embossed on the brass handle of the chain. Now we'll see the example of a metric chain. This figure shows this is a brass handle. On this handle, marking is there, the length of the chain, and this is a swivel joint which we discussed earlier, and this is a link, each link connected with oval rings, and provided with a brass tallies at every 5 meters. 5 meters, 10 meters and 15 meters. So with a different shape it is provided: 5 meters, 10 meters and 15 meters. Next is measuring tapes. Second variety of instrument used for taking the linear measurements is tape. Tapes are used for more accurate measurements. The tapes are classified based on the material of which they are made, of such as cloth or linen tape, fiber tape, metallic tape, steel tape and inward tape. Most probably fiber tapes are in practice, and nowadays these fiber tapes are also replacing with the plastic tapes. I will discuss about the fiber tapes a little. Metallic tape. A linen tape reinforced with brass or copper wires to prevent stretching or twisting of fibers is called a metallic tape. As the wires are interwoven and the tape is varnished, these wires are visible to naked eyes. This is supplied in the leather case with a winding device. Each meter length is divided into 10 parts, that is decimeters, and each part is further subdivided into 10 parts, that is equal to 1 centimeter. So it is commonly used for taking offsets in chain surveying. This is a tape wounded in a case, and provided with a ring at the entry point. The ring is also taken into count for the distance. Next type of tape generally used is a steel tape. The steel tape is made up of steel ribbon of width varying from 6 to 16 mm. The commonly available lengths are 10 meters, 15 meters, 20 meters, 30 meters and 50 meters. It is graduated in meters, decimeters and centimeters, and modern tapes may be having millimeters is also marked, steel tapes. So steel tapes are used for accurate measurement of distances. This is an example for steel tape. Next instrument is arrows. Arrows are made up of tempered steel wire of diameter 4 mm. One end of the arrow is bent into a ring of diameter 50 mm and the other end is pointed. Its overall length is 400 mm. Arrows are used for counting the number of chains while measuring a chain line. An arrow is inserted into the ground after every chain length measured on the ground. Now we'll see how shape of the arrow. This is the arrow having a sharp edge at the bottom and at the top having a ring, so that it can be easily packed. This is another type of arrow, steel arrow. Next is next instruments used is a ranging rod and offset rod. Ranging rods are used for ranging some intermediate points on the survey line. Ranging rods are generally 2 to 3 meters in length and are painted with alternate bands of black or white or red and white color with a length each equalizing 20 centimeters. The purpose of painting is to identify them from a larger distance. The location of any survey station can be known from long distance only by means of ranging rods. If the distance is too long, a rod of a length 4 to 6 meters is used and is called ranging pole. The offset rod is similar to ranging rod, with the exception that instead of the flag, a hook is provided at the top for pushing and pulling the chain or the tape. It is also used for measuring the small offsets in the chain survey. These are ranging rods. Ranging rods are provided with a sharp edge at the bottom so that it can be easily inserted into the ground. Pegs. For marking the stations, generally pegs are used. Permanent marking of stations can be done by using the pegs. Pegs are made up of timber or steel and they are used to mark the position of the station or terminal points of a survey line. Wooden pegs are 15 centimeters long and are driven into the ground with the help of a hammer or mallet. These are the wooden pegs which can be driven into the ground. Its exact shape will be like this one, having a 150 mm in length and 25 mm in cross section, marked with a nail at the center. So that the exact station point can be marked by using the pegs. Next is plumb bob. Plumb bob is used to transfer the points on the ground. It is also used for fixing the instrument exactly over the station point marked on the ground by checking the center of the instrument whether coincides with the center of the peg or station or not by suspending the plumb bob exactly at the center of the instrument under it. Plumb bob is thus used as a centering aid in theodolites and plane table. Let's see the figure of plumb bob. This is the plumb bob having a steel made with a steel with a rope. Next is operation. First operation generally done before taking the linear measurement is known as ranging. That means aligning a straight line is known as ranging. When a survey line is longer than a chain line, it is necessary to align intermediate points on chain line so that the measurements are along the line. The process of locating intermediate points on survey line is known as ranging. There are different methods of ranging: direct ranging and reciprocal ranging. And direct ranging can be done by using the minor instrument called a line ranger. It is an optical instrument used for locating a point on a line and hence useful for ranging. It consists of two isosceles prisms placed one over the other and fixed in an instrument with handle. The diagonals of the prisms are silvered so as to reflect the rays. So the person standing at the intermediate point in a perpendicular direction can use the line ranger. With a plumb bob, the point C can be transferred. So now I will explain how it will be operates. The advantage is it needs only one person to range a line. The instrument should be occasionally tested by making 3 points in a line and standing on the middle point, observing the coincidence of the ranging rods. If the images of the two ranging rods do not appear in the same line, one of the prism is adjusted by operating the screw provided for it. This is a real figure of a line ranger. Consists of two prisms, one up and down. I will see it in detail. To locate a point C on the line AB, the surveyor holds the instrument in the hand and stands near the approximate position of C. If he is not exactly on the line AB, the ranging rod at A and B appears separated as shown in figure B. Like this. These are separated in the figure. The surveyor moves to and fro at right angles to the line AB till the images of ranging rods at A and B appear in a single line as shown in figure C. So see the figure C, both the ranging rods will coincide. Then it happens only when the optical square or line ranger is exactly on the line AB. Thus the desired point C is located on the line AB. Next is direct ranging. The ranging can also be done by direct ranging, but at here minimum 2 persons are required. If the first point and last points are indivisible, this method is possible. Stations A and B in which an intermediate point C is to be located. The point C is selected at a distance slightly less than a chain length. At points A and B, ranging rods are fixed. The assistant holds another ranging rod at near C. Surveyor positions himself approximately 2 meters behind the station A and looking along the line AB, directs the assistant to move at right angles to the line AB till he aligns the ranging rod along AB. Then surveyor instructs the assistant to mark that point and stretch the chain along AC. So AB are the straight line not in a straight line if we are not done the ranging. So while making the ranging rod, it should be to the plumb. This is right way and this is wrong way. So it should be to the plumb line while making. Now let's see AB points are the end stations which are intervisible. We have to locate a C point intermediate point. The surveyor stands behind A and asks the assistant to move left or right, so has to locate the C point exactly in line. Now D point is located on the line, C is also locating. Now exactly from C you can able to locate the D point. So alignment can be done like this one so that measurement can be exactly obtained between A and B. So once the alignment is over, the surveyor gives a signal to mark the point on D. Next method is indirect or reciprocal leveling. Due to intervening ground, if the ranging rod at B is not visible from station A, reciprocal ranging may be resorted. Figure shows this scheme of ranging. It needs two assistants, one at point M and another at point N, where from those points both the stations A and B stations B are visible. It needs one surveyor at A and another at B. To start with M and N are approximately selected, say M1, N1. Then the surveyor near end A ranges the person near M to position M2 such that A, M2, N1 are in the line. Then surveyor B directs the person at N to move to point N2 such that B, N2, M2 are in the line. This process is repeated till the A, M, N, B are in the line. Please see the figure. So the person standing at M and N has to move from M1 to M2, M3 and M, so that at the final you will be having A, M, N and B are the in a straight line. I will see in detail about it. Let high ground is intervening between the 2 points A and B. Then we have to select points C1, D1. The person standing at C1 and D1 will direct with each other so that A and B are fixed, C1 and D1 is moved, such that C1 moves to new position C2 such that A, C2 and D1 will be in a straight line. Similarly, the person standing at C2 directs person standing at D1 to a new position D2 such that C2, D2 and B will be in a straight line. Until this process will be continued until from person standing at A can able to see ACD is in a straight line, and similarly person standing at B can able to see that ADC is in a straight line. Then this problem will be solved. The indirect ranging can be solved. The reference books for this is Surveying and Leveling, Volume 1 by Kanetkar, Kulkarni, and Surveying and Leveling by N.N. Basak, Tata McGraw-Hill, Surveying Volume 1 by B.C. Punmia, Lakshmi Publications. Internet websites are also given it here. Thank you.